talk Gauss method and Gauss-Seidel method. Okay, so for this Gauss method, it's literally elimination method. So the goal is we want to, okay, we'll first of all arrange this equation, make them look okay. I think here it's well arranged. So here we want to eliminate 2x and 3y, 2x. So we have y and z here. Then here we want to eliminate 3x and y. So we have just this guy here. So literally what it is to eliminate x here, they multiply this place by 2. They multiply equation 1 by 2, then use equation 2 to subtract equation 1. So if you do 2 times this, 2 cancels 2. Then by the time you say 2 times y, it gives you 2y, right? But 3 minus minus, because remember I'm saying equation 2 minus equation 1, so 3y minus minus, it comes plus. So 3y plus 2y gives you 4, it gives you 5y here. The same thing goes here. Z plus 4, it gives you 4y. Then minus 1, minus 1 times 2, that's minus 2. Then yeah, 13 plus 2, it gives you 15. Then the same thing goes here. You multiply equation 1 by 3 to cancel out on this end. So when we did that, we got this. Then they went ahead as to divide all three here by 5, since 5 can divide this equation equally. Then after they did that, they go here. And remember I said our goal is we don't want 4y in this place. So what they did is they used equation 2 and 3 to do the same thing we did by multiplying this guy, multiplying this equation by 4, so they can cancel. So if you multiply 4 here, 4y cancels 4y, right? Then we say 4 times z, that's 4z. So 10 minus 4, we get 6. Then 4 times this is 12, right? 18 minus 12, we get 6. So now this is actually a very simple thing, because when we look at this equation alone, we can divide both sides by 6 to make z the solution of the formula. So we immediately did that, we got our z to be 1, right? So we now input our z into equation 2, right? So which is y minus 1 equals to 3. So by the time y plus 1 equals to 3, so by the time we cross this over, it became 3 minus 1, 2. We found our y. So in this equation now, we're going to input our y and our z. So we got our x to be 3. But I don't really know if this is going to come out though. But let's just go to Gauss-Seidel method. So this Gauss-Seidel method is the same thing as Jacobs, but the difference is so clear. In Jacobs, I think you're going to round up after you bring to the right hand side, making x, y, and z is sort of formula in each equation. You're going to make, in this first equation, your y and your z will be 0. Here, your x will be your answer from this equation 1, and your y and z will be 0, or your z will be 0. Then here, in this z, equation 3 of z, your x and y will be your answer from 1 and 2, right? But let's just go. Let's not jump. So what we did first is we brought everything here, make x the sort of formula in equation 1, y in 2, z in 3, right? So here we have 6x, so we divided all through by 6. So 105 divided by 6, I think 3 went through, that's why we have 35 over 2. Then 1 over 6, 1 over 6, yada yada. And here we divided by 8 because y is 8. And here we divided by 10 because it was 10z, right? So we have equation 1, 2, and 3. So as I said, in our equation 1, we are going to make y and z 0. So by the time we put 0 here, 0 here, it cancels. So our x is equals to this, right? So in equation 2, we are not going to say x and z is 0. No. It's in Jacob equation, you will assume 0, 0, 0, 0 in equation 1, 2, and 3. But this one, no, you don't do that, right? So when you come to your y, we are going to input our answer of x, our previous x, which is 35 over 2, into the equation, right? Can you see it used to be 1 over 2, so 35 over 2 times 2, 4. Then our z will be 0. So now that we know our y, we'll come to our third equation. So our y is 88 over 8. And when we input the equation, I think division kind of took place. Yeah, 2 over 5 times 88 over 2 over 5, right? Times 88 over 8. Punch into your calculator. I'm sure you get 17 over 4. That was it. So remember what I said. The difference between this guy, Gauss-Seidel method, and Jacob is here in the equation 2, you don't assume your x is 0. You make it the answer you got from equation 1 because you just found your x in equation 1, right? So let's just continue. After you do that, now you are going to repeat the process in this table. So as you can see in this table now, if you want to go the second iteration, what we'll do is our y, which is 10.6, right? That's what we are going to use in this equation 1 of our x. Where's our equation 1 of x? I think this equation 1 of x here. Yeah, so here now our y is going to be the equation, the answer we know, which is 17.632 over 5 and what not. So can you see exactly again starting from equation 1, putting y and z. So now we know our y and z. We are not assuming they are 0 anymore. We are using the answer we have here, 88. Answer we have in our first iteration, 88 over 8 and 13 over 2 as our x and z. Can you see? That's what we are putting in our equation 1, and we are going to get 14.6, and we input it here. So yeah, I don't think there's anything else to learn. Just know that the difference between this guy and Jacob is Jacob, you just assume everything is 0. Then it's the next phase when you are calculating that you begin to use your x and y and z. That's when you are restarting, like they restarted here, to find iteration 2, iteration 3, iteration 4. So bye guys.